Today we're going to look at moles and their relationship to volume. 1 mole of any gas takes up 22.4 liters at STP. So this relationship is true, and what makes it so important is the any gas part. So this doesn't work for a gas, this works for all gases. It is something you have to memorize, that 1 mole is 22.4 liters. I would recommend writing it in your reference table on the back so you don't forget it, but if you do take a Regents, you definitely want to memorize that, because it's not you're going to get a clean reference table for the Regents, obviously. So the reason this works is because when you vaporize gases, the molecules get so far apart that the intermolecular forces pretty much go to 0. And so that's actually part of, if you remember KMT for an ideal gas, is that there's no attraction between molecules. And what it means to us is that at the same temperature and pressure, all gases are going to have roughly the same density. And that's why this works for all gases. It does not work for liquids and solids because their densities will vary greatly for various reasons, but unfortunately for us, it does work for gases. So the way you do it is pretty simple. You're just going to set up a ratio, and this part, so here's my first question. 45 liters of oxygen gas, how many moles would it be? So here's the good thing. As long as it says gas, I don't care about the fact that it says oxygen. That does not matter. I'm going to set up a ratio to solve my problem. So I memorized this, and I'm just going to do it right over here. 1 mole equals 22.4 liters. And now I'm just going to put my mole over mole and my liters over liters. So in this case, I want moles and I have liters. So now you just cross multiply and divide out to get X, and you get rounded 2 moles. And it's that simple. And that's all you do. Let's do the next one. 100 liters of H2O gas. Again, the H2O part doesn't matter as long as it's a gas. That's all that's important. And they want to know how many moles that is. Well, always label this stuff. It's another issue that you need to constantly do. I see students doing that all the time, or not labeling. And what it leads to, and again, you could round this or not, for 4.5 doesn't make a difference. What it leads to is putting in the 100 under the moles and the mole number under the liter number, and then you get it wrong. So make sure, this is part of the reason we write the units in, because I want to make sure that my 100, my liters goes over liters, and my moles goes over moles. The next one, we change it up, 4.5 moles, how many liters it is, so still using the same ratio, except now I have moles. And then I just put my X on the liter side. Again, cross multiply, solve for X. 100.8 liters. And then for our units, you should include the formula on these. And that's, again, just a habit to get into so that we don't make mistakes later on, because we will be doing more complicated calculations like this in this unit, and having everything labeled is going to be very important. The last one of this type. Again, rounding doesn't count, you just call that 19. Now, for these problems, these are a little bit harder, okay, because they say grams. So the fact that it's a gas, that's great, and for 5 and 6, it's the same problem. But this only works for moles and liters. It does not work for grams and liters. So for this type of problem, you're going to have to use the mole formula. And we're going to solve for moles before we do the problem. So I've got 12 grams of O2. So there's my 12 grams. And my GFM for O2 is 32. So I just divide out, and I'm going to get 0.375 moles of O2. So now when I go once I have that, I do a regular problem. So I just take this answer, plug it in there. Now I do my ratio, and I get 8.3 2.4 liters. One more time, it's going to be 200 grams for glucose. It weighs 180. Figure out the number of moles. It's 1.1 moles of. Then we do our ratio. And again, this would be glucose gas. Obviously, you're almost never going to see that in real life, but it's just a practice problem, so it doesn't really matter too much. And we get 24.8 liters of. And this one would be, we should probably put that these are gases as well. All right, and that's everything for converting moles to liters. It's all pretty straightforward. You're mainly using the ratio. Sometimes you may have to use the mole formula with it, but it depends on the problem.